All right. So we're going to start off on the desktop like we always do. We're going to come into Terminal, and I'll zoom in here a little bit. The first thing is to get our environment activated. So we'll do a conda end list to remind ourselves of where our environments are. I've got 3 here. The one we've been working with is in the sample project folder. So I'm going to go conda activate and then copy this. I could copy and paste it, but I'm just going to type it out because that's what we're in the habit of doing. So we've got users/Daniel/desktop/ML course. Oh, typos galore today. /sample project. Your file path here might be different, unless your name's Daniel, because otherwise, great name. And then here, once we've got our environment activated, we can see that this has changed from base to this string here. Wonderful. That means our conda activate environment is activated. So then we'll go here, Jupyter Notebook, so we can get our notebook server loaded up. Wonderful. This is going to open our browser. I haven't changed directory, so that's why I'm at the top folder here, but that's all right. I can change into desktop, ML course. Sample project is where we've been working. We've got our introduction to matplotlib, numpy, and pandas notebooks. Wonderful. But I'm going to create a new one because we're going through introduction to Scikit-learn. Wonderful. We'll put a beautiful heading up the top here. Introduction to Scikit-learn, brackets, sklearn to remind ourselves. And we go, this notebook demonstrates some of the most useful functions of the beautiful, which it is beautiful, Scikit-learn library. Wonderful. We'll hit escape and M to change that into markdown. We'll run it, and maybe we'll put in here what we're going to cover, just so we get a little bit of a highlight. What we're going to cover. So we're going to start off with 0, because we're going to index Python style. 0 will be an end-to-end Scikit-learn workflow. Wonderful. And then we're going to deep dive into each step of this workflow. So we'll look at getting the data ready. Then we'll choose the right estimator. Now, estimator is another word in Scikit-learn you'll see in a second for machine learning model. So when you hear the word model or machine learning algorithm or estimator, that's what sklearn uses for it. They use the term estimator for machine learning model. We'll put /algorithm for our problems. 3, we'll fit the model /algorithm /estimator and use it to make predictions on our data. Wonderful. And then 4, we'll look at evaluating a model. And then 5, we're going to improve a model. And then 6, we'll save and load a trained model. And then 7, why don't we put it all together? Maybe putting it all together sounds a bit better there. Wonderful. All right, well, let's dive into it. Let's start with 0. We'll create another heading. So 0, an end-to-end. Now follow along if you can, because that's the best, but I'm probably going to go a little fast, to be honest, because I'm kind of just talking through this as I go. So if you can't keep pace, that is absolutely fine. You could potentially slow the video down or just revisit it a few times until you see what's going on. But don't worry, you'll have access to all this code here. So an end-to-end Scikit-learn workflow. And we got the steps right here of what we have to do. So let's do it. Step 1, getting the data ready. Let's see what that looks like. We've had a little bit of experience in the past few sections on using a heart disease data set. So let's see if we can do that and maybe build a machine learning model on that heart disease data set. All right, so we'll do 1, get the data ready. Import pandas as PD. Now remember this, the end-to-end Scikit-learn workflow, we're going to kind of breeze through these steps. So we'll deep dive into each of them as we go. So we'll go heart disease equals pd.read_csv. Now I believe I've moved everything into a data folder. So usually we could just put the CSV name here, but I've changed it up and now all of our CSV folders are within this data folder. Just to kind of clean and keep our sample project folder nice and neat looking. So that's why I've got the file path data here. Data heart disease.csv. And then we'll go heart disease. We'll view it just to make sure. Wonderful. There's all of our rows there. And so what we're going to do with this is use these columns all across here. Age, sex, CP, whatever these are, to try and predict the target, which is 1 or 0, heart disease or not. So the first things first is we need an X. And you'll see this a lot in Scikit-learn. X is kind of the features matrix, which is essentially these columns, and then Y will be this column. So let's see how we do that. So we create X, maybe we'll put here, create X, which is called features matrix. Oftentimes, it has other names, could be data, could be feature variables, heart disease dot, we want to, every column except the target column. So we need to go axis equals 1, beautiful, and then we're going to create Y, which is label matrix, or labels, let's just call it labels, beautiful, Y equals, we want heart disease, now we only want the target column for target. Wonderful, so we've created X and Y, so basically X and Y, X is just these here, and Y is this column here. Wonderful. Then what's next in Scikit-learn? We go up here, 2. Choose the right estimator / algorithm for our problems. Well, our problem is classification because we want to classify whether someone has heart disease or not. So let's see that in action. So 2 is choose the right model and hyperparameters. Hyperparameters are like dials on a model that you can tune to make it better or worse. So let's use a random forest. So Scikit-learn, if you're wondering what is Daniel talking about with random forest, well, we're going to see this in a little more depth in a future video, but just so you're aware, just imagine random forest from scikit-learn.ensemble, import random forest classifier. This is just a classification machine learning model. That is the most you need to know for now. So it's capable of learning patterns in data and then classifying whether a sample, aka a row, is one thing or another thing. And so we'll instantiate that class using CLF, which is short for classifier in Scikit-learn. Other times you'll see it called model, but we're going to use CLF because we'll stick with the documentation. So CLF equals random forest classifier. Beautiful. And we'll keep the default parameters, hyperparameters. Keep the default hyperparameters. So CLF, you can see what parameters your model's using CLF.getParam, so we'll see this. Maybe take a little while to import. In the meantime, we'll create the heading for this one. So 3 is fit the model to the data. Wondering why that's taking so long. Maybe it'll finish while we're typing. So first of all, we need to train our model on a training set and test it on a test set. So we need to create that. What is this? Oh, my bad. We need this. It's not an attribute. It's a method. There we go. So this is the hyperparameters or the little knobs on our machine learning model random forest classifier. We'll have a look at these in a future section. But we want to also fit the model to the training data. Beautiful. Let's do that. So we want to go from sklearn.model selection. We need to split our data into training and test. And we can do that with sklearn's train test split. Train test split. Wonderful. And we're going to go xtrain, xtest, ytrain, ytest equals train test split xy. Test size, we want test size to be 0.2 or whatever size you'd like to put in. Essentially what this is going to do is split our data from x and y into xtrain, so training data, and ytrain, xtest and ytest, so testing data. So if you recall from way back in section 1, we usually fit the model to training data and then evaluate it, see what it's learned on test data, so data it's never seen before. And what's this test size? Well, that means that 80% of the data will be used for training because it's 0.2. because test size is going to be 20%. So if we had 1,000 rows, 800 of them would be used for training, and 200 of them would be used for testing. But we're getting distracted here. This is a whirlwind tour of Scikit-learn. We want to go CLF, now we want to fit it. We can do that with clf.fit xtrain. This is basically saying, hey, classification model, random forest, find the patterns in the training data. We'll go Shift and Enter. Beautiful. This is going to give us a little warning here because there's something that's happening. So let's read them. Future warning, the default value of n estimators, which is a parameter. We go up here, n estimators, warning. That makes sense that it's giving us a warning. Will change from 10 in version 0.20 to 100 in 0.22. Well, let's see if we can just update that now. So n estimators, we're altering our hyperparameters here, equals 100. Now, we shouldn't get that warning. Beautiful. We don't. And we can get rid of that output by just putting that little semicolon. Excellent. Now, our model is fit to the data. So what can we do? Well, we can make a prediction. So let's do that. Make a prediction. This is still step 3, by the way. Y label equals clf.predict, and we have to pass a numpy array. So let's do that. Numpy array 0, 2, 3, 4. Let's see what happens. We get an error. Numpy is not defined. We should have done this right at the top. Let's do that. Import numpy as np. Beautiful. Now this should work. No, it doesn't work. Why doesn't it work? The input. So the shape isn't correct. Now, the reason this is because when you train a model on something that looks like xtrain, which xtrain happens here, we can only make predictions on arrays that look like this, because that is what our model has learned. So, does this np array 0, 2, 3, 4 look anything like this? No, not at all. But what does look like that is xtest. Beautiful. So what we can do is we can make some predictions. So ypreds is a conventional name for making predictions on test data, equals clf, our model, dot predict xtest. Now what does this look like? Ypreds. We've got an array of zeros and ones, and now what does this look like? We've got ytest. We also have an array of zeros and ones. I wonder what we could do with this. Well, we can go step 4, evaluate the model. This is where we evaluate how good the predictions or how well the machine learning model we've just trained, our random forest classifier, has done learning on the training data. So ytrain. Let's do on the training data, and test data. This is what we're doing here. So clf.score. Wow, it's actually done very well. So this is going to return, if we press Shift Tab, the mean accuracy on the given test data and labels. So we've passed it the training data. So the model has done 100%, 1.0. That's the maximum you can get with score on our training data. Let's see how it's done on the test data. Now, if it gets 100% on the test data, we might think that something's wrong. Beautiful. Excellent. So what has happened here? Well, the model has found patterns in the training data so well that it's got 100%. Why? Because it got trained on the features. So way back up here, it got trained on these as well as the labels. So it had a chance to correct itself if it got something wrong. But it performs at 75% accuracy, which means it gets 3 out of 4 predictions correct on the test data because it's never seen that data, nor has it ever seen the labels. All right, so there are some more metrics that we can use rather than just accuracy. So let's see that. From Scikit-learn.metrics, import classification report because we have a classification problem. We want a confusion matrix. And why not accuracy score, just to see another way of getting the same thing that we have here. So we'll start off, we'll go print, we want classification report. And we want to compare, what does this take? We can't press Shift Tab because we haven't imported it yet. I believe it takes ytest, so test labels, so true labels, versus our predictions. So what this is going to return is spoiler alert, let's just see it. So what this shows us is some classification metrics that compare the test labels to the predictions, the prediction labels that we made up here with our model. So we're using the predict function. And then if we do the same again, we can do our confusion matrix. So we got confusion matrix, and we want y test versus y preds. Wonderful. And then we can do accuracy score, and we want y test, y preds. Beautiful. These are just some more steps that we can do to evaluate our model. And so next step would be, we're not really happy with how the accuracy score is doing there. So let's go to step 5, which is come back up here, right to the top, improve a model. Okay, let's do it. Let's see how we can improve a model. We might go try different amount of n estimators, which is one of the hyperparameters, aka dials on our machine learning model, that we can tune to try and improve it. So let's see this in action. MP, we'll start off with a random seed where our results are replicable. MP random seed, and we want for I in range 10, 10, 100. Step can be 10. We go here, and we want print. We'll give it a little communication, trying model with I estimators. Wonderful. Oh, we've hit Shift Enter too quickly. It's like I'm trigger happy. And again, my goodness. Okay. Now then we want to go CLF equals, we'll instantiate another model, random forest. Can we press tab, classify? Beautiful, we can. Thank you, autocomplete. Now estimators equals I. Wonderful. So this is going to loop through and try 10 and then 20 and then all the way up to 100 estimators, because we're trying to figure out if we can improve our model by adjusting one of the hyperparameters, because that's step 5, improve a model. And so we'll go print f model accuracy on test set. We'll go model.score x test, because we want to evaluate our model on the test data. So it's going to learn on the training data and then evaluate itself on the test data. And then we'll put a little bit of a percentage sign here. Maybe limit it to 2 decimal places. Does that make sense? Let me read back this. Model accuracy on test set. Model score. Yep, we're just adding a little bit of communication here. And then maybe we'll print a space here so we can kind of see it. Let's see this in action. Trying a model with 10 estimators. Why didn't this work? Name model is not defined. Oops. See, I told you model can be used. We need CLF. So CLF, remember, is short for classifier. And let's do it. How come it's not working again? Random forest classifier is not fitted yet. Call with fit. Yes, we've instantiated, but we haven't. How are we trying to score a model we've never fitted on our data yet? We have to do this here. See, this is great. Live coding, full of errors. Wonderful. Now, if we would look back through this, you would say that the best model with the best accuracy, if we go back, is 20 estimators. Well, there we go. We've gone from, what was our original one? 75% to 83% by adjusting one of the hyperparameters of our model to 20 instead of the default, which is 10 currently, but it's going to be updated to 100. And we're going really fast through here. But what's a final step? We go back up here, right to the top, save a model and load it. Okay, let's do it. So we want to go 6, save a model and load it. Now we can save a model with Python's pickle library. So we're going to import pickle, and then to save our model, we'll go pickle.dump. We'll pass it our model, aka CLF for classifier. And we'll pass it also, we'll give it open with the file name that we want, if I can remember this, random forest model1, fancy name, haha, pickle, and then we want to write binary with WB. Wonderful. So this is going to save pickle.dump. See, I'm not even following my own motto here of if in doubt, run the code. Now this should have saved a model to file. Let's go up and have a look. If we refresh this, beautiful, random forest model there. Now what happens if we try to import that? So we want to go loaded model equals pickle.load. We want to go open, pass it the file name, random. Can we do that? Yes, we can. Tab autocomplete. And now this time we need RB followed after that, read binaries. And then we'll go loaded model dot score x test y test. See what happens. 73. Now that should line up 73.7 with the last model that we tried up here. And it does. Wonderful. Now we've just zoomed through that. It took about 20 minutes or so to do an entire scikit-learn workflow with a lot of talking. So we started off with getting the data ready. We saw our data frame of heart disease. Then we split it into X and Y, which is often what you'll do in supervised learning problems in scikit-learn. We're going to use the features here to predict the target. Wonderful. And then we chose the right model. We kind of skimmed over a bit of how you'd actually do that, but from experience, I know Random Forest Classifier is pretty good at doing classification problems. So we'll see how to do that. And then we decided to use the default hyperparameters, which are those little knobs you can turn on a model. Then we saw how to fit the model to the training data, so aka a model finding patterns in the training data. And first of all, to even get our data from a big set into training and test, we use this little helper function from Scikit-learn. Thank you, Scikit-learn. And then we made a prediction, or at least we tried to, and then we realized, hold on, our model can't make predictions on things that aren't the same shape, because remember, Scikit-learn is built on NumPy arrays. So if we pass it an array, this bad boy here, that isn't the same shape as the data that it's trained on, now it's going to throw us an error. So we fix that error by asking our model to predict on X test, which in turn it predicted a label, Y preds, for each of our samples. And then we compared our predictions to the Y test through evaluation. Now our model got 100% on the training data, but only got 75% accuracy on the test data, which actually is still pretty good. A coin toss for 0 or 1 would be 50%, so our models are halfway to being the perfect model. And then we go here. We tried a few more classification metrics, so we got a little bit more of an insight rather than just accuracy. We did a confusion matrix, and we used the accuracy score function. And then step 5, we tried a bunch of different hyperparameters, aka different estimators. We found out that maybe 20 estimators is the best for our model because it got the highest accuracy. And then finally, we saved a model and reloaded it, and it got the same score as our most recently trained model, which was 90 estimated 73.77. And now, this is a whole lot to take in. I completely understand that. We've gone through it relatively, or actually quite fast. But what we're going to do is break down each of these steps throughout the next few videos. So if you want to, go back through, try and put all the code that we've used into one cell if you can, and see if you can get a model trained. Can you get it saved? Can you get it re-import? Have a little practice. But otherwise, I'll see you in the next video, and we're going to check out how to get our data ready for using it with machine learning models.